All right, this first example I'm going to show you has a cosecant in it. It's 2 cosecant squared theta minus 5 equals 3. Now, this example is really just built to kind of get you thinking about the trig function as your variable, even though technically theta is the variable here. But we're going to be treating the entire cosecant squared as the variable until it's solved by itself, and then you can go on from there and solve for the theta. All right. So some instructions here says solve using exact values on this interval from 0 to 2 pi. So that tells us right away that our answer is going to be in radians, right? We don't want degrees here. 0 to 2 pi is clearly radians. And we're going to use exact values. Now, exact values typically should signal to you that we're going to use one of the 2 special triangles, right? You're either going to be working with a 45, 45, 90 triangle, or the 30, 60, 90 triangle, which I drew almost like the 45, 45, 90. Here we go. A little bit better. Alright, so I'll just sketch those up there. Ooh, my 3 doesn't look like a 3. There. We'll just sketch those up there so they're referenced. And then from there we can, that'll be towards the end. We'll deal with that at the end. Okay? So first of all, right now, I just want to isolate the cosecant squared. I've got to get that thing by itself, right? This thing right here. So I want to eliminate all the stuff that's around it. Well, just like you would if you were solving the equation 2x squared minus 5 equals 3, you would add the 5, divide by the 2, and then eventually you'd have the x squared by itself. Well, this is really no different. Okay, the process that we're going to use to get the cosecant squared by itself. So we're going to add the 5 to both sides. We're going to get 2 cosecant squared theta equals 8, right? And then we're going to divide out the 2 from both sides of the equation. 2's drop off. You get cosecant squared theta is equal to 4. Okay? So there, we've solved for the cosecant squared. That's a good first, well, maybe not first step, first several steps, but a good first goal. Okay? Once we've got the cosecant squared solved for, I want to get rid of the square, right? I want it to just be the cosecant. So we're going to utilize the square root property we talked about before, which is where you take the stuff being squared and set it equal to the positive or negative square root of the other side, right? So we saw this before. If this were x squared equals 4, then x is plus or minus the square root of 4, which is plus or minus 2. Well, here instead of x, we're looking at cosecant theta. That's what's being squared. All right, so we could write that then as just cosecant theta equals plus or minus 2. All right, so now what we're looking for are all angles theta that make the cosecant equal to either positive or negative 2, and we can use any angle in the interval from 0 to 2 pi. All right, so any of the 4 quadrants. So I'm not really familiar with cosecant. Not as familiar as I am with the sine. And remember that cosecant and sine are reciprocals. So anytime the cosecant is equal to positive 2, that just means the sine is equal to 1/2, right? The reciprocal of the 2. So this would tell us then that the sine of theta must be equal to the reciprocal of these. So the reciprocal of 2 is 1/2, the reciprocal of negative 2 is negative 1/2. So that must be plus or minus 1/2. So whenever the cosecant is equal to positive or negative 2, that must correspond exactly to the angles where the sine is equal to positive or negative 1/2. Once we have this in terms of the sine, I can then go to my special triangles. Well, 1/2 is the sine of an angle. It's the 30-degree angle, right? Because the sine is opposite over hypotenuse, and the sine of 30 is 1/2. All right? So that means theta is basically a 30-degree angle. However, I want to find all angles, and this could be in any of the quadrants, where the sine is positive or negative 1/2. Okay? Well, remember, ASTC, the sine is positive in the first two quadrants and negative in the third and fourth quadrants. Okay? And so, in the first quadrant, the 30-degree angle is what will work. In the second quadrant, to get the other one for the plus, that would be what? It'd be 180 minus 30 to go the other way, so that'd be 150, right? 150-degree angle. Now, I'm putting all these in degrees just because it's quick, but ultimately I need these in exact form radian mode, right? Mode, like on a calculator. 30 is what? Pi over 6, right? Remember the 30 and the 6. So I know right away that theta is going to equal pi over 6. That's one of my answers. What's 150 in radians? Well, think about every 30 degrees is a pi over 6. This would be 5 of them, right? 5 30-degree angles. So it's 5 pi over 6. It's also 1/6 less than a pi, right? 1/6 less than 6/6 is 5/6. Yeah. Okay. So those are the two that correspond to the positive 1/2 value. Now we look at the ones that correspond to the negative 1/2 value. The negative 1/2 value comes from the two bottom quadrants, the third and fourth quadrant. Okay. Now in the third quadrant, we go 30 degrees past 180, which is 210. Right, that's a 210-degree angle. Well, it's also 7 pi over 6, right? It's 1/6 further than just 1 pi. So it's 7 pi over 6, or you could think of 710 as 7, you could think of 210 as 7 30-degree angles. So it's 7 pi over 6. And then you get around the fourth quadrant, where again, the sine is negative 1/2, and that's going to be what? It's 360 minus 30 degrees, so that's 330 degrees, 330. Which of course that's 11 pi, right? It's 11 30s going around. So that'd be 11 pi over 6. And so these four angles are exact value in radian form, and they all are in my interval from 0 to 2 pi, and they satisfy the original equation, right? In fact, if you were to plug any of these into your calculator to solve, you would get that to work out. In fact, I'll verify it just to show you. I'll just do it with one of them, and then you could do this with the rest of them. I'm going to first make sure that I'm in radian mode, which I'm not to start. No, I'm in radian mode. Now what I would do is I would type in now this is a little bit tricky because I've got cosecant here. I don't have cosecant here. So I'm going to use 1 over the sine. It's going to look a little weird. I'm going to use parentheses. I'll show you as I finish this off. 1 over the sine of pi over 6. And then a parenthesis, and then I'm going to square that. And hopefully I have room. I kind of have room there. -5. Yes, I think you can see this. Whoa, maybe. If it'll zoom without too much of a glare. Okay, I don't know if you can tell. Alright, so that's 2 times 1 over the sine, right? 1 over the sine is the secant. Pi over 6. I squared it, so I have a parenthesis around the entire 1 over sine portion there. So you square the 1 over sine portion, and then you subtract the 5, and that should give you 3. And that should give you 3 because that's what we had on our equation. So basically by plugging in pi over 6 here, it makes the left side equal to 3, which is on the right side as well. Okay? So it makes them equal out to each other, which is what they should do. If you did the same thing and just put in 5 pi over 6, 7 pi over 6, and 11 pi over 6, you get exactly the same thing to work out. Okay? So these 4 angles are the 4 angles that will solve that equation.